Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 2 of 10 good problems on the chapter of squares and square roots. I have already completed and solved the set 1 problems on this chapter. I hope you have watched that video. If not, then I request you to watch that video also. Uh, this series of videos, in this series of videos, I come up with 10 HOD problems, that is high order thinking problems from a chapter as and when the chapters are completed from the other playlist, that is CBSE Maths 8 RS Agarwal. So this video is part of the playlist Maths 8 HOT. HOT stands for high order thinking, where I solve 10 good problems from a chapter. Uh, it is recommended that you first try to solve the problems yourself, and if you are stuck, then only you see the solution, this solution video as a reference. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the 10 good problems, set 2 on the chapter of squares and square roots. Okay, so I have the 10 good problems from the chapter squares and square roots on the left hand side. These are all MCQ questions where there are 4 choices for each question and 1 choice is correct. So there are 10 questions. 10 questions. So while I will solve the problem, I will pause for few seconds after after solving a problem, and you can take a screenshot of the solution if you think it will help you. Okay, let's start solving the problems. Okay. Problem number 1 says, if m is a square number, what is the next immediate square number? It is said that m is a square number, that is m is a perfect square. Then what is the next immediate square number? Now, so if m is a perfect square, m is a perfect square, is a perfect square. So this implies square root of m is its square root, is its square root. So this implies the next square number, the next square, since m is a perfect square, definitely square root of m will be a natural number, which is its square root. So the next square number will be equal to the next natural number. So square root of m is a natural number. This is a natural number since m is a perfect square. So this is a natural number whose square is m. The next natural number of square root of m will be square root of m plus 1. So this is the next natural number after the square root of m, and hence the next square number will be the square of this number. And we know, applying the a plus b whole square formula, we know a plus b whole square is equal to a square plus 2ab plus b square. So square root of m plus 1 whole square becomes square root of m square plus 2 into square root of m, 2 into ab. So a is square root of m, and let's say b is 1. So 1 and plus 1 square. So this is equal to m plus 2 twice square root of m plus 1. So this is the next square number, and the So the correct choice is B. Okay, let's solve the problem number 2. It is given that if 3 into root 5 plus square root of 125 is equal to 17.88, then the value of, then it has asked to find the value of uh, square root of 8t plus 6 into 5, 6 into square root of 5. We have to find this value. Okay. Now what is, let's see what is square root of 8t plus 6 into 5. This is equal to, what is 8t? 8t is equal to 8 into 10, and we have plus 6 into square root of 5. Now what is, let's further factorize 8 and 10. What is 8? 8 is 4 into 2. 4 into 2, 45. Okay, and we have over here 10 is 2 into 5, and we have 6 root 5. So this becomes 4 into 4 into 5 plus 6 into root 5. So this is 4 square multiplied by 5, square root of 4 square multiplied by 5, and plus 6 root 5. Now this is square root of, we know that this is square root of 4 square multiplied by square root of 5, plus we have 6 square root of 5. We applied the formula square root of a and b, a into b, where a and b are positive numbers, is equal to square root of a multiplied by square root of b. So now this is square root of 4 square is obviously 4, and we have multiplied by square root of 5, and this is equal to plus we have 6 square root of 5. So now this becomes 4 square root of 5 plus 6 square root of 5. So this is equal to 10 square root of 5. So the given value, given expression, that is square root of 80 plus 6 into square root of 5 becomes 10 into square root of 5. Now let's see what we are given. We are given 3 into square root of 5 plus square root of 125 is equal to 17.88. This implies 3 into square root of 5 plus 125, we can write it as 25 multiplied by 5 is equal to 17.88. So now this equal to 3 into square root of 5 plus we can write it as square root of 25 multiplied by square root of 5, that is equal to 17.88. So this implies 3 times square root of 5 plus square root of 25 is 5. We have 5 into square root of 5 is equal to 17.88. So this implies 8 into square root of 5 is equal to 17.88. So this implies square root of 5 is equal to 17.88 divided by 8. So from the given given information that 3 into square root of 5 plus square root of 125 equals to 17.88, we have found, from there we have found square root of 5 is equal to 17.88 by 8. So this implies 10, we have to find the given expression that is square root of 80 plus 6 into square root of 5 is equal to, we have found to be 10 root 5. So this implies 10 root 5 is equal to 17.88 divided by 8 multiplied by 10. So this is equal to 178.8 divided by 8. Now we can see that the number so 1788 is divisible by 8 because the number formed by the last so a number is divisible by 8 when the number formed by the last 3 digits is divisible by 8. So we have to see now. Okay, so what is so this is into 10, so this is 178 by 8. Now what is 178 by 178.8 by divided by 8? We have 2, 16, 1, 8, 2, 16, 2, we have 28, we have 3, 24, and 4 and 5. So the answer is 22.35. This is the value of the given expression, that is square root of 80 plus 6 into square root of 5 is equal to 22.35. Hence the correct choice is B. Okay, let's do problem number 3. It is asking to find the square root of an expression is given x to the power, this is x to the power m square minus n square, and then multiplied by x to the power n square plus 2mn multiplied by x to the power n square. We have to find the square root of this. Let's say this b equals to y. So we have to find square root of y. So we have to find what is square root of y. Let's first simplify what is the value of y. So we can say that y equals to, we see it is a product of 3 exponential terms where all the bases are same x and the powers are different. So we will add the powers. The base will remain the same, that is x, and the powers will get added, that is m square minus n square plus n square plus 2mn plus n square. This is equal to x to the power n square gets cancelled. This is m square plus 2mn plus n square. Now this is equal to the power is in the form of m plus n whole square. We know that the identity a plus b whole square is equal to a square plus twice ab plus b square. So applying this identity of a plus b whole square, we can say the power becomes m plus 1 m plus n whole square. So now we have to find the square root of m, square root of y. Square root of y is nothing but y to the power half. Y to the power half. Now what is y? Y is x to the power m plus n square, and this whole raised to the power half. So this becomes we know that applying the laws of exponents, that applying the laws of exponents, that x to the power m and this whole raised to the power n is equal to x to the power, the powers gets multiplied, that is m into n. Applying these laws of exponent, we can say that square root of y becomes x to the power half multiplied by m plus n whole square. So this is x to the power m plus n whole square by 2. So the correct choice is A. Okay, let's do problem number 4. It is a simplification problem. So we have to simplify square root of 32 plus square root of 48 divided by square root of 8 plus square root of 12. Now, one general strategy might be to multiply the denominator, both the denominator and the numerator, by square root of 8 minus square root of 12, but that will not really help much. It is better if you can simplify all the square root terms further, because all the numbers inside the square root have some factors. They have factorize them and then try to see if you can take out any common. So square root of 32, I know it is 16 into 32 is 16 into 2, okay, and 48 is 16 into 3, and we have 8 is 4 into 2 plus 12 is 4 into 3. So this becomes now square root of 16 into 2. I can say I can write it as square root of 16 multiplied by square root of 2, and then we have plus square root of 16 into 3. We can write it as square root of 16 multiplied by square root of 3, applying the properties of square root, that square root of x into y is equal to square root of x multiplied by square root of 5, and we have divided by square root of 4 into 2 is square root of 4 multiplied by square root of 2. Similarly, we have here square root of 4 multiplied by square root of 3. So now we can see square root of 16 is 4. So we have 4 square root of 2 plus 4 square root of 3. And the denominator is square root of 4 is 2. So we have 2 square root of 2 plus 2 square root of 3. So this is from the numerator. We can take common, and we have 4 into square root of 2 plus square root of 3, and from the denominator we take 2 common, and we have 2 into square root of 2 plus square root of 3. So square root of 2 plus square root of 3, this gets cancels out, and we have 2. So the correct choice is B. B is the correct choice. Okay, let's do problem number 5. Find the smallest square number which is exactly divisible by 24, 48, 72 and 60. So we have solved this kind of problem while discussing the theoretical videos in the playlist CBSE Maths 8 by S. Agarwal. How do we find the smallest square number which is divisible by some given numbers? So the given numbers are 24, 48, 72 and 60. We have to find the least square number which is divisible by all these numbers. Now first we find what is the least number which is divisible by all these numbers, and that least number is the LCM, least common multiple. So we have to find first the LCM of 24, 48, 72 and 60. So let's find out what is the LCM of 24, 48, 72 and 60. So let's divide by 6, we have 4, 8, 12, 10. Let's divide by 2. We have 2 minus 4 minus 6 minus 5. Let's divide by 2. 1 minus 2 minus 3 minus 5. So the least common multiple will be 6 into 2 into 2 into 2 into 3 into 5, which is equal to 10. This is 10, 30, 60, 120. This is equal to 720. Really? This much big? 720. Okay. 720. Okay, so the LCM of these numbers is 720. Now what do? We have to find the least square, which is divisible by all these numbers. So the least number which is divisible by all these numbers is 72. That is their LCM. Now we have to prime factorize. Okay, 720 to find the smallest square number which is exactly divisible by this. Okay, so this is the 720 is the LCM of these numbers, that is the least number which is divisible by all these numbers. Now we have to convert this from this 720 number, we have to see what is the least number that we can multiply with 720 so that it becomes a perfect square. So what do? So we have the prime, so the factors are 6, which you can say is 2 into 3, and then we have 2 into 2 into 2, and then we have 3 into 5. So how do we solve the problem which asks what is the least number that need to be multiplied to a given number to make it a perfect square? We first find the prime factorization of that number, and then we try to form pairs of equal factors. So that is what we will exactly try to do. So we know that 720 is the least number that is divisible by all these numbers, and we know the prime factorization of 720 is 2 into 3 into 2 into 2 into 2 into 3 into 5. Then we will create pairs of equal factors. So we have 2 into 2, this is one pair, and again we can have 2 into 2, this is another pair, and we have 3 into 3, this is another pair, and we are left with 5. So if we can multiply this number 720 with 5, so 720 if we multiply with 5, then we will get a complete set of pairs of equal factors. So 720 multiplied by 5 will become 2 square multiplied by 2 square multiplied by 3 square multiplied by 5 square, and this is equal to 2 into 2 into 3 into 5 whole square. So it is becoming a perfect square, and which is the least number. This is the 5 is the least number that when multiplied by 720 we get a perfect square. So the smallest square that will be divisible by all these numbers is definitely 720 multiplied by 5, which is 3600. So the correct choice is C. C is the correct choice. Let's do problem number 6. Which of the following is not a perfect square? Okay, so we have to select the choice which is not a perfect square. We have some products of exponential terms. So let's see what is A. A is 4 to the power 6 multiplied by 5 to the power 6 multiplied by 6 to the power 6. So we see these are all exponential terms where the powers are same. So we can write it as 4 multiplied by 5 multiplied by 6 raised to the power 6. Now the power 6 can be, we know, so this is 4 into 5 multiplied by 6. The power 6 can be written as 3 into 2. 6 is equal to 3 into 2. And now we can say this is equal to 4 into 5 multiplied by 6 raised to the power 3, and this whole raised to the power 2, because we know the law from the laws of exponents that x to the power m, this whole raised to the power n is equal to x to the power m into n. Okay, so now this term, this is a square. So this is equal to, we can say 20 and 120. So this is 120 cube square. This so this is a square because it is a square of cube of 120. So this is a square. So this cannot be a correct choice because we have to choose the number which is not a perfect square. So this is a perfect square. Anything any number of the form a to the power twice n is a perfect square, where n is a natural number and a is also a natural number. So this is a perfect square. So a cannot be the choice. So let's see what is b. B is 4 to the power 5 multiplied by 5 to the power 5 multiplied by 20. So this is equal to 4 to the power 5 multiplied by 5 to the power 5, and 20 is 4 multiplied by 5. So if I combine the exponential terms of 4 and the exponential terms of 5, this becomes 4 to the power 6 multiplied by 5 to the power 6. This is equal to 4 multiplied by 5 whole to the power 6. This is equal to 20 to the power 6. This will be equal to 20. As before, like a, we can say this is equal to 20 cube whole raised to the power square. So this is also a perfect square. This is also a perfect square. Okay. So this cannot be a choice. Let's see what is C. C is 4 to the power 4 multiplied by 5 to the power 4 multiplied by 6 to the power 4. Now clearly this is equal to 4 into 5 into 6, this whole raised to the power 4. So this is equal to 120 raised to the power 4, and this is equal to 120 square, and this whole raised to the power square. So this is also a perfect square. This is also a perfect square. So this cannot be the choice. So obviously the choice D will be the correct choice, and choice D cannot be a perfect square. Anyway, let's see what is choice D. 4 to the power 4 multiplied by 5 to the power 5 multiplied by 6 to the power 6. Now this is equal to, we can say 4 to the power 4 multiplied by 5 to the power 4 multiplied by 5 multiplied by 6 to the power 6. This is equal to, we can say 4 to the power 4 multiplied by 5 to the power 4 multiplied by 6 to the power 4 multiplied by 5 and multiplied by 6 square. Now this is equal to 4 multiplied by 5 multiplied by 6 raised to the power 4, and we have over here no, let's not split the exponential term of 6 with base 6. So this is equal to 4 to the power 4 multiplied by 5 to the power 4 multiplied by 6 to the power 6 multiplied by 5. So this is equal to, we can say that 4 this is 4, we can say 4 square, and 5 square whole raised to the power 2, and this is 6 cube whole raised to the power 2. You have to be very aware of all the laws of exponents. We have this. So now this is equal to 4 square multiplied by 5 square multiplied by 6 cube whole square multiplied by 5. Now this cannot be a perfect square, not a perfect square because of the factor 5. This part is a perfect square, but this is not a perfect because of the factor 5. This number is not a perfect square. So the correct choice is D. D is not a perfect square. Okay, let's do problem number 7. It is given that A is equal to 0.1039. Then we have to find the value of 3a minus square root of 4a square minus 4a plus 1. Okay. Now 3a minus what is 4a? We have 4a square minus 4a plus 1. This is equal to 3a minus, we can clearly see that inside the square root, the term, the expression, the algebraic expression will be a form of a whole square. So 4a square is 2a square, square of 2a. Now minus 4a, we can write it as 2 into 2a and into 1, and we have plus 1 means we can say 1 square. So applying the formula or identity of a minus b whole square, we know a minus b whole square is equal to a square minus 2ab plus b square. Applying this identity, we can say this will become 3a minus, inside the square root the term becomes 2a minus 1 whole square. So this is equal to 3a minus square root of a term, square root of a square is a, so we know that square root of x square, where x is a number, positive number, that is not positive, x is a non-zero number, this is equal to x. So we have this is equal to 2a minus 1. So this is equal to 3a minus 2a plus 1. This is equal to a plus 1. A plus 1. Now, so this is equal to, what is a? A is given to be 0.1039 plus 1. So this is equal to 1.1039. 1.1039 is the answer. So the correct choice is C. C is the correct choice. Okay, let's do problem number 8. What must be added to the following expression to make it a perfect square? So we are given an expression 3x square by 16 minus 15 into square root of 3x divided by 14 and plus 127 by 49. We have to convert this to a perfect square. So since this is an algebraic expression, we have to convert this in the form of a plus b whole square. Now not a plus b, since we have the negative term, that is the minus 15 into root 3x by 14, clearly we have to form a minus b whole square. Now 3x square by 16, 3 can be, this can be written as, now 3 can be written as square root of 3 whole square, and we have x square, and we have 16 is 4 square, minus 15 square root of 3x by 14. One second, friends, someone is at the door. Okay, so okay, uh, so we have 15 into root 3x by 14. This can be rewritten as okay, so this can be rewritten as now root 3x by 14. Is it 14? Now what should be added? It is saying what must be added to the following expression to make it a perfect square. Okay, let's for the time being forget about the term 15 into root 3x by 14. Now what is 127 by 49? 127 49. Clearly 127. So we can see that this 49 is 7 square. 49 is 7 square, and minus 4. Now this term will be we know that a minus b whole square is equal to a square minus 2ab plus b square. And now we can see that the a in this expression, that is root 3x. What must be added to the following root 3 by 4. Now this is equal to, we can write as root 3 into x by 4 whole square. So somehow the a is, we can see that a, this is, if we consider this as a, so a is root 3 into x by 4. So if this is a, to form a minus b whole square, we must have minus 2 into this a, as we have a minus b whole square is equal to a square minus 2ab plus b square. Now the b square will come from the term 127 by 49, and minus 2ab has to be the term minus 15 into root 3x by 14. So if that is the case, then we must have minus 2 into the a is root 3 square root of 3 into x by 4. So we have 3 x by 4. So this is a, and we must have b. Now what can be b? 127. 127 is uh, now what can b be? So we must have b over here such that whatever the b is, such that this whole thing uh, should be equal to 15 into root 3x by 14. I think in the given problem there is a mistake that this is not actually square root of 3x, but this is actually square root of 3 into multiplied by x. This should be the actual expression. So there is a problem in the issue in the given expression in the problem. I'm sorry for that. I might have written it improperly, incorrectly. So this is 15 into square root of 3 into x by 14. So what can b be such that we must have so we must have 2 into square root of 3 into x by 4 into b, we must have this equal to 15 into square root of 3 into x by 14. Square root of 3 and x cancels out, and this implies b is equal to 4 by 2 multiplied by 15 by 14. B is equal to 4 by 2. Okay, and so this becomes this 2 and this 7. So this is 15 by 7. So B has to be 15 by 7. Okay, B has to be 15 by 7. So I will write over here 15 by 7. Now to complete the a minus b whole square, I must have plus 15 by 7 square. It is asking what must be added to the following expression to make it a perfect square. Okay. Okay. And we already have now so let's say x need to be added. Let's say y need to be added to make it a perfect square. So I am omitting this part. This step is little incomplete. Okay, so we have this. Now so we have found that the b must be 15 by 7 and a is root 3 square root of 3 into x by 4. And to form the a minus b whole square, we are adding 15 by 7 whole square. And since we have added this, we have to adjust it by subtracting the 15 by 7 whole square, and we have let's say y need to be added. Okay, and so we have and then we have the plus y and plus 127 by 49. Okay, so this becomes equal to root 3 x by 4 minus 15 by 7 whole square, and we are left with y plus 127 by 49. Now clearly so we have also this minus 15 by 7 square. Okay. Now clearly, so we have assumed that y need to be added to make it a perfect square. So we have already have this perfect square, that is a minus b whole square. So somehow we have to make this part y plus 127 by 49 minus 15 by 7 whole square, this part has to be equals to 0. So this implies we must have y plus 127 by 49 and minus 15 by 7 whole square is 15 square is 225 and 49. This must be equals to 0. So this implies y is equal to 225 by 49 minus 127 by 49. This is equal to 225 minus 127 by 49. This is equal to 8, 15, 3 and 9, 98 by 49, and this is equal to 2. So 2 must be added to make the given expression perfect square, which will be in the form of a minus b whole square, that is root 3x by 4 minus 15 by 7 whole square. So the correct choice is C. C is the correct choice. Okay, let's do problem number 9. Let's do problem number 9. Find the value of, okay, so we have to find the value of square root of 63 plus square root of 56. So this is equal to, we know, square root of 63 is 9 into 7 plus square root of 56 is 8 into 7. So this becomes square root of now square root of 9 into 7 is square root of 9 multiplied by square root of 7, and we have plus square root of 8 into 7 is equal to square root of 8 into square root of 7, applying the properties of square root, that square root of x into y is equal to square root of x multiplied by square root of y. So now this is equal to square root of 9 is 3. So 3 into square root of 7 plus square root of 8 is equal to square root of 8. We can write it as square root of 8 is 4 into 2, and we have multiplied by square root of 7. This is equal to square root of 3 into square root of 7 plus square root of 4 into 2, we can write it as square root of 4 multiplied by square root of 2, and we have multiplied by square root of 7. Okay, this is equal to square root of 3 into square root of 7 plus square root of 4 is 2. So 2 into square root of 2 into square root of 7. Now we can take, if we from the expression inside the square root, if I take square root 7, I get square root multiplied by 3 plus 2 into square root. Okay, 3 plus 2 into square root of 2. Okay, find the value of square root of, okay, find the value of square root of 2 into 2 into square root of uh, square root of 9 square root of 7 63. 3. Okay, so fine. Square root of we have square root of 7 multiplied by, now this term 3 plus 2 into square root of 2, 3 can be written as 2 plus 1 plus 2 into square root of 2. So this is equal to square root of 7 multiplied by 2 can be written as square root of 2 whole square of square root of 2, and 1 can be written as 1 square, and we have 2 into square root of 2. So this term is becoming a whole square, term. So we have square root of 7 multiplied by, we are getting square root of 2 plus 1 whole square, whole square. So this is equal to, now this is equal to square root of 7 multiplied by square root of 2 plus 1 whole square. We just applied the fact that square root of x multiplied by y is equal to square root of x multiplied by square root of y. Now what is square root of 7? We know that, you must know that square root of x means x to the power half, In general, nth root of x means x to the power 1 by n, where n is a natural number. So this is nothing but square root of 7 to the power half, and we have here square root of root 2 plus 1 whole square means square root of 2 plus 1. So this is again equal to 7 square root of 7 to the power half, this whole to the power half, multiplied by square root of 2 plus 1. So this becomes 7 to the power 1 by 4 multiplied by 1 plus square root of 2. Now 7 to the power 1 by 4 is nothing but fourth root of 7, and we have multiplied by 1 plus square root of 2. So the correct choice is C. C is the correct choice. Okay, let's do problem number 10. Problem number 10 says, what is the smallest natural number which when added to the difference of squares of 17 and 13 gives a perfect square? What is the smallest natural number which when added to the difference of the squares of 17 and 13 is 17 square minus 13 square. So what is the smallest natural number which when added to the difference of ato gives a perfect square? Now we know that given a number, what is the smallest number which when added to it makes a perfect square? So we have to find the square root using the, we can find the square root using the long division method, and then whatever the remainder is, that will be whatever the remainder is, we have to find the square root, and whatever the quotient is, that quotient plus 1 whole square minus the given number should be the smallest number that should be added to a given number to make it a perfect square. What can we add to 17 square minus 13 square? To make it a to give a perfect square. Now 17 square minus 13 square, this is equal to, we know using the applying 17 minus 13 multiplied by 17 plus 13, using the identity that a square minus b square is equal to a minus b multiplied by a plus b. If we use this identity, then 17 square minus 13 square is 17 minus 13 multiplied by 17 plus 13. This is equal to 4 multiplied by 30. This is equal to 120. So what is the smallest number? So we know that the smallest number is 121, because we know that 121 is equal to 11 square. So this implies the smallest number to add to 120 to make it a perfect square is definitely equals to 1. So the correct choice is A. A is the correct choice. So this brings to an end in solving the set 2 of 10 good problems on the chapter of squares and square roots. This sort of problems will be a good practice or evaluation of your understanding on the chapter of squares and square roots. So I will keep on coming up with 10 good problems for all the chapters that I complete in the other playlist, that is CBSE Maths 8 RS Agarwal, so that you have a good practice of your understanding of the chapter concepts. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Please stay tuned for more this kind of videos on 10 good problems for all the chapters that I complete in the other playlist. So thanks for watching, and until the next video, take care and bye.